is political, corporate data economic, probably the company does not, anything is clean, okay? And non-profit civil organization that adverse the company, then the true reason is, are the only way to obtain some kinds of data. Okay, please. This is a list of pioneering project focusing on exposome perspective. We starts with the 2007 in the USA with the EPA project Toxcast. Toxcast is an integrated database. Then we can attempt to link to the database if possible. Then as development H-throughput screening to test on biological system by chemicals. In the 2012, EU founded a very big project called FP7 Exposomics. That is the first attempt to go toward an holistic way of exposure. Mainly, this project is clinical project. And then the data are essentially data about epidemiology, molecular biology, and classical, let me say, omics approach. In the 2015, there is it's interesting, this project funded by EU. This project is the CEURAT, and a joint project between governments and the company that produce personal care and cosmetics in order to reduce the animal testing during the developmental phase. This is very interesting. Why? Because in a perspective of bioinformatics, so ICT, this project offers the possibility to use mathematical modeling to substitute the animal, or almost to substitute to create or to model a reduced animal to test specific compound. It's more or less an evolution of system biology. 2 years ago, EPA has improved the previous project in ExpoCast. Then also EPA is going toward to Exposome. Please thank you. There are some key points for risk assessment process. Normally, this is these key points are a classical key point. The hazard identification. Identification in which way compounds can induce adverse effect. Adverse effect in general sense can be from molecular to cellular to, let me say, developmental phase. The dose response assessment is a classical dose response that is not changed as the traditional approach. The exposure assessment is the determination of doses and time of exposure in which the population is incurred. For instance, a population can occur in a single heavy pollution events and then stop. Otherwise, a population can be subject to a low level of contamination for years, for centuries. Then what is the difference of you accept a low dose, but for a long period? The behavior, the dynamical behavior of a dose is a little bit different, not a little bit, is different. Because a single traumatic event can directly induce death. But on the long term, a low dose can create more damage than a single event. The other is the last point is the risk characterization. The risk characterization is a from an ICT point of view, could be considered as an optimization problem. What is the idea to mitigate? I cannot remove anything, any pollutants, but I can optimize the process to reduce the risk. Then the mitigation could be, in an ICT point of view, see as an application of optimization technology working on multiple different data. Thanks. Okay, this you can see an overview of exposure science. You have, as in the previous slide, you can see environmental monitoring is the source of pollutants, but it's important also in the data collection for an exposure, for a SPOSON project to identify what kind of sources, chimney, traffic, hospital, or what you want. The second is the environmental distribution. There's different water, air, and soil, and the difference, the persistence of pollutants in the different compartments. The environment is capable to degrade many compounds, or there are some factors that increase the toxicity of the compound. The water is important because the air is the most important, because if the rain the fallout of the rain, of contaminated rain, increase the contamination of the soil and obviously also the water. The exposure medium, air, water, food, contaminated food, not only for the use of pesticide to preserve the crop, but also for the pollutants absorbed by the plants. For instance, heavy metal can be absorbed by plants, and you can eat contaminated tomato, contaminated lettuce, or what you want. Toxicological external exposure, internal exposure. Talking about another thing is important, is a very interesting aspect of pollution is the use of consumers' products such as cream, personal care, and also the pills that one uses for therapy. External exposure is evaluated by monitoring, but internal exposure is evaluated by biochemical tests. You can analyze the urine, blood, other biofluid at the moment, and more essentially you can find this data into clinical record. The target exposure, having a general landscape of the pollutants in my biofluid, I can go to found the genes, the proteins, the cells, the tissues, and the organs. This is a top-down approach. At the end, the molecular analysis using in vitro approach, essentially, give an estimate of altered outcome. Please stand. Okay. There are another important project in Exposome. There is the difference from aggregate exposure pattern and adverse outcome pattern. The first identify how the sources, you can see here the chemical, the first is the source. This is adverse aggregate exposure pattern. The source give a key event one. There is a problem. The key event is the element critical for the pollution. You can see the different the source generate another key event in exposure medium, water, air, soil, what you want, and external exposure originate this chain that is a possible way to impact the target site of exposure. The target site of exposure, obviously, at this moment is molecular. This analysis show there is only one adverse outcome pattern. But as you can see here, different aggregate exposure pattern can cooperate on the same target. Then the problem is this guy, for exposome, is to identify how many aggregate exposure pattern can affect a specific target. For instance, coming to the illicit drugs. Illicit substances impact more or less the same target, not the new synthetic one. But what is the contribution of a mixture of cocaine and crack on the same adverse outcome pattern? I am talking about this topic because I am working with my regional government on analysis of new illicit substances. The other, you can see here, for instance, we have three AAP elements that cooperate on the synthetic, on the same AOP. This is endocrine disruptor systems. You can see APA, phthalate, unfortunately, and the difference, you have different elements that go to the estrogen receptor. That is, endocrine disruptor is a big problem, but you can see the two possibilities. Two AAP that have two different activity, two different impact, and different AAP that cooperate for the same damage. Then you can consider that that a mixture of pollutants have a big problem, have a big impact on the health. Thanks. How to approach this thing? Experimental, as I said, environmental monitoring is okay. The personal monitoring now, some guys has developed some tools to monitoring in real time your personal level of contamination using the sweat. You have a similar smartwatch, you can put your smartwatch, and the smartwatch is able to detect from your sweat the level of contamination. The computational far field model are satellite, fixed point, platform, near field exposure, near to the source, and the other are computational dynamical model, because you, in these phases, you must to detect, to estimate the dynamic of degradation of pollutants and their pharmacokinetic property. For instance, at this level are embedded tools similar to QSR, augmented toxicity, are similar model for user to do dynamical model. And the other is the reverse toxicokinetic model that, given the data of toxicity, is a reverse engineering process. Thanks. Okay, this is the. I refined the previous slide because now we're more related to the pharmacological aspect. The computational model or dynamical model, statistical and machine learning model, because at the end of the history, chemoinformatics is essentially based on machine learning on a larger amount of compounds to find lead compound, or in this case, to rank the toxicity of compound, the binding of toxicant. The other is the docking model, QSR, that is traditional. And the system model, biology model, that we're going toward a virtual cell model. Now there are some suits that allow to perform some model of the compartment. There is some model that working that simulate the liver or other thing. And the experimental assay are high throughput screening, high throughput content that are the same that you are learning in your course, because there is only a difference of the aim of the analysis. And molecular epidemiology include all these things into predict into link the epidemiological information with the data. Oops, there is some small problem. The battery. No. Waiting this thing, I would like to underline I hope that you have understood what is the complexity of the process. It's not to find antibiotics or to analyze a biochemical network. Now the big problem before to go on is to find the key point and in which way is they, for each modules, they can cooperate for the goal of an exposome project. Here it's not enough to have engineer. The problem is to find the core of the project, because of define the project and define to have a brainstorming to define what is the first thing to do. If okay, you can see we can go here to is similar to the previous, but give to a framework of the multiscalar response. In this slide, roughly speaking, you have more or less 20 different experimental approach. You can start from molecular modeling. We can go to the high throughput screening. We can go to at this level. You can must to study the protein stability, that is a very, or nucleic acid stability, that is very important, because some experiment that use the PEG inside the cell have to demonstrate that the intake of compounds can modify not only the ionic strength inside the cell, but also the conformation. Changing the conformation, one can change or reduce or the efficiency of a specific reaction. The protein stability, unfolded region, misfolding, or on the DNA, the change of conformations, the modification of post-transcription and post-translation modification kinetics are modified. At cellular level, viability, you must have a cell culture, or you can use a body chip in which many tissue are on a single chip. This is the process that anyone know, apoptosis. You must have a test to this proliferation, differentiation enzyme. You go to the inflammation tissues, the necrosis, the classical evidences of a damage, until the clinical, that is structural deficit, for instance, some or functional deficit disease. The disease is what the clinicians say, what the people say of a healed person, but what is inside is all the other part of the plane. Thanks. Okay, this is a proposal about how to is a proposal of a workflow to work on exposure alignment. This is the concept of exposure alignment. I have two different set of data coming from different exposure studies. They must merge together. It's not an alignment of protein. It's an alignment of a set of different data that must be aligned. There are, in fact, this is the very basic. Why? Because in cell-free, what the structure in the previous slide, there is protein binding, degradation, loss of functionality. This is classical for mutagenesis and other. But you can align cell-free with metabolism and uptake the particle size. This is the intake of pollutants. Then to cell-free, we must merge together cell-free and cell-based assay. Then after, there is a very interesting and critical point, that is the air-liquid interface. You must characterize how the stressor that you have decided, the chemical pesticide, what you want, what are their chemical physical property, and what are their property to be spread in a specific environmental compartment. Or if in a specific compartment, I make an example. There is the pollen in the air, and there is the PM10 organic compound. In the PM10 there is also pollen. But you can imagine that pollen can absorb chemical pollutants. Then instead one molecule of chemical pollutant, when one breath intake pollen with more molecules, then increase the intake of not only of the pollen but also the chemical substance. Then what happens in the air? The sun radiation can modify the chemical structure of pollutant and so on. Or in the soil, the example is given by my Indian colleagues of endosulfan. There is microbes that convert when endosulfan forming is a form that is more critical. Then, now I said before, there is molecular information and then evaluated on organ on a chip. This is strictly related with the possibility to develop system biologic simulator. In the previous project about the cosmetics, many of experimental data are carried out not on animals but on organ on a chip, because it's not an animal but is a sample of skin or what you want, and then can test it without using the animal. Animal model in any case are useful because in the last step is also at the moment a traditional element of the protocol. In the future could be cancelled and used only computational or high throughput systems. Why? Because they are biokinetic data. Biokinetic data of animal, biokinetic data if you're working on health, human health on human. Then you must align or merge together in order to formulate a function that take into account the outcome of each one of these modules. Then when I have the outcome of each module, I must develop a cost function in a mathematical term that allows to make the prediction on the impact of different aspects of the exposure. Thanks. Okay, there are. This is by point the different pivotal elements of for exposure science. Alignment, as I said before, improving the exposure assessment, because now integrating different sources is not enough to use the canonical measures. We must study new functions. You must study new optimization tools to do this. The exposure is based on a priority given by the organizer of the panel or the analysis, and this predicting exposure is important in the new approach for sustainability, because the exposure is a preliminary study. For instance, in the case to study new plastics, before to go to plastic production, many companies such as BASF has decided to study before the exposure, study the degradation, study the components released by the plastic before to go in the industries. Identify the mitigating sources of exposure. This is even if this is an approach, that optimization approach, because we must, or also machine learning based, because the evaluation and mitigation is a rule generation process. Assessing the cumulative exposure, taking into account a mixture of contaminant. Normally, one use 1-2 contaminants to make the toxicity test. Now it's important to study a mixture of contaminant, and the tool at the moment are quite, for my knowledge, is normally working on a single contaminant or analyzing a set of contaminant one at a time. I have a set and analyze the toxicity one contaminant at a time, not using a mixture of this contaminant. Please. Okay, definition of the type of exposure: near field and far field exposure. Near field is environment stress resulting from the chemical proximity of the subject. Tobacco smoke. Okay.
We have to break the tea.
Okay.
Continue after
10 minutes. Continue or
after tea you can
okay. Thank you.
we break.
Okay. 5 minutes.